Howdy folks. Well, I thought I'd make a nice little tutorial here for you regarding the latest rat tibia homework project, and just to get you started and hopefully clear up any problems, especially for the new people in the class. So I'm going to do this basically from scratch. I've already unzipped some of the files and put them in their proper directories. I'm just going to show you where these are. First of all, I've taken the work Tochnog directory files and I've placed them in my Matlab program directory, which is located here, as you can see, under computer disk C, users tcdo Matlab work. This is where I've decided to put my Matlab work program files, and I've placed them here in this directory, and there's no spaces in the path name. It's very important. Okay, so the next thing I did is I went and I set my path. So I've already set the path, so this is the path to those files, users tcdoe Matlab work. You can put them anywhere you want, just make sure it's in your path. Now I've also placed all the data files in this directory. On my computer it's o/classmats/hw1 rat tibia. Okay? And I'm in that directory right now. This is my working directory and the directory where the image files are saved. Okay. First things first, we have to update the paths in the actual programs themselves. So let's look at the programs. They're located here in my editor. Alright. I've already opened the programs, so you see tibiafaa, write talk rat, read talk rat, ratplot3, the header file, and I actually have the output data file open here too. So if I move down to the end of tibiafaa, I see that there are some functions that have to run. Write talk rat. So first let's just take a look at write talk rat, and you'll see at the very end of the file or the script there's a command. This is the command that writes all of the Tochnog input file. Alright, it attaches the header to the data and then outputs the talk file dat, which is what Tochnog uses to run the FEA analysis. So this path, as you can see, I've typed it in here. This is the path to the header file, to my hw1 rat tibia working data file. You have to update that to your own path wherever you selected. Next place to do that is in tibiafaa, and that's located here on line 294. This is the command line that actually runs the Tochnog finite element solver. This is the input file, and then it outputs it to this output file. Okay, so you have to update this path as well. Alright, and I believe that's all. Now, I'm going to run tibiafaa. Now that my paths are all updated and everything, I'm going to go ahead and run tibiafaa, and we'll see what happens. Tibiafaa. Okay, here's the images. Start from it says select first image file, so I'll do that. I'll double click on srcap0. And in a second, I didn't click fast enough. In a second, you'll see a figure window appear. And now it's time to do the tracing. So I'm going to do this very quickly. I'm going to select my callus, 1, 2, 3, 4. I'm going to hit enter. Now I'm going to select the bone. 1, 2. I'm doing this very quickly. 3. You can make a much better tracing of the outline. 4. Notice that I'm placing those points, as I mentioned in class, on the inner rim of the circle. Alright, I'll put one here, and one here, Now I'll double click on the last one to close it up. The mesh appears, and now we can watch the tracking progress. Okay, almost done. And the tracking looks good. And we're done. Now we wait for a minute while the finite element analysis program runs. And if everything goes well, a figure window will appear. Give it a second. And a plot should appear. Aha, this looks great. Okay, so I have an increasing Y force at the tip near where the ram is. That's this point here. Okay. And what is that force? Well, this is in newtons. So that's 0.35 newtons, which is approximately 350 grams. Okay, now just to take a look at our results, and close this figure window, and now I'm going to plot the results showing the X stress. So in order to do that, I have to move up a directory, and then I have to run rat plot 3. And here we go. Okay, so this looks very reasonable. Running rat plot 3 shows quite a few things. It shows that we have a bending stress that looks reasonable. We should have tension on the lower surface and compression on the upper surface, and that's what we've got. It looks like the forces are a bit unbalanced here, and this is an issue because this is running in displacement control, so it's not a perfectly vertical force. So that's something that I'd like to update in the future. But for now, this is good enough, and what we're going to do is I'm going to close this window now that I've been able to visualize it, and we're going to look at the program and make a few adjustments. Okay, so what do I want to do? I want to, according to the assignment, I want to adjust the moduli. So I will go back to the editor. This is always a challenge. Tibiafaa editor, here we go. Okay, so here I am in the editor. And so what do I see I need to do? I'm going to need to reduce the modulus because the modulus of the callus is too high. I'm getting approximately 350 grams, but if I looked at the data file, let's just take a quick peek at the data file. If I look at the data, the actual raw data from the experiment, it looks like the peak force is around 100 grams. So I want to reach 100 grams, which is 0.1 newtons approximately. So let's go ahead and adjust those values again. And we're assuming that the bone, a 1 megapascal apparent modulus is reasonable for the bone. So let's try and reduce the modulus of the callus. Let's make it 200 kilopascals. So I'm going to have to run this part of the analysis again. So I don't have to go through the whole tracing. I can just select this part of the script and I can run it again. Or alternately, I can copy these commands and put them right into the command window. Paste and run. Okay. All right. And once again, we should get some values. Okay, so we've reduced the callus modulus, and now, as you can see, we have a reduction in the end force, which means we're getting closer. Okay, I'm going to close this, and let's take a look at the result again. Now, I'm left in the Tochnog directory, so I have to go back up a directory in order to do the plotting. we go. The new result. Okay, as you can see, the new result looks very similar to the previous one. It's just that basically, by reducing the modulus, the magnitude of the forces is decreased. Okay, there's a variety of other things that we can do. We can change other parameters of the analysis in a very straightforward way, simply by adjusting values in the header file. This is the header, and as you can see, this is where we have various different values for the material properties, as I showed in class. Let's do something like, just for example, let's just adjust one property. Let's make this 0.1, which is a fairly low Poisson's ratio. Save it, and then re-execute the previous commands. Now, when I say re-execute the previous commands, as soon as I start doing something like that, I tell myself, well, why should I be cutting and pasting? Why don't I just make another little script in order to be able to re-execute these? So I'm going to do that. I'm going to select these commands that I used, copy them, go back to the editor. Let's make a new script, paste them in here, and I'll give it a little name. We'll say script to recalculate FE. Alright. And I'll save it. And I'll just go ahead and save it in the rat tibia folder. And I'll call it FE recalc. How's that? FE recalc. So now all I have to do, instead of going through all of those issues, is just type FE recalc here. I have to make sure I'm in the right directory. And it appears that I am. In order to do the FE recalc, I have to be in the main images directory, because it's going to go into the Tochnog directory all by itself. FE recalc. Alright, wait for it. Still waiting. Up, here we have a solution. And voila, we have a new solution. It's not much different than the old solution, though. Maybe a slight decrease. Let's take a look at the stresses. CD rat plot 3. And what do we see? Well, not a huge difference, but there is some difference. This is softened just a little bit. It's kind of hard to tell from this plot. You can manipulate those parameters and try different things. Okay, that's about it for this tutorial. Now your job is to go ahead and try and find some bone and callus modulus values that appear to make sense. What might happen is, if you continue to reduce the callus modulus, you might end up with a problem. As a matter of fact, let's just go ahead and try it one time. Let's go back to the callus, and let's reduce it to 1. Sometimes, if you have two wildly different moduli values for two different adjacent materials, they can cause a problem. Now, just to hopefully we'll be able to verify when this is done. Right, so just to be sure, you can see a large decrease in the peak force And you can also see that our callus modulus has changed appropriately to what we asked for. Alright, let's take a look at that result. And here we go. Okay, once again, the result looks reasonable, not much different, and just the magnitudes of the forces has changed. Alright, that's it for this little tutorial. I'm going to go ahead and post it. Bye for now.